Okay, what are the requirements for this lab? Okay, basically we're going to configure static route, OSPF, access list, and DHCP, for the different requirement of this lab itself. As you can see that basically for start, we actually need to do some connection on the cell itself. As you can see that for R3 and R4, there is no connection. So if you were to look at the settings or the requirement under section D, it actually mentioned to you that you need to insert a serial card, HWIC-2T or to R4, because currently R4 doesn't have any serial interface card for the serial connection. So basically double click on R4, switch off R4, and drag and drop HWIC-2T onto slot 0 of the router and power up the router again. Next, we will need to actually go to the connection main category and select a DCE serial DCE cable. So as mentioned in the requirement under D, you are supposed to connect R3 serial 000 to R4 serial 000. So click on the router, select serial 000 interface and connect to R4 serial 000 interface. That will actually fulfill the requirement of D for the connection between the router before we actually start to do the necessary configuration to fulfill the requirement. So before we actually start off the configuration, something to think of. So basically we need to do some basic configuration on the router itself. So you can see that we need to assign a device name to all the router, configure the privileged executive encrypted password as class, which is the second level password of the router, and to configure the console and PTY password as Cisco for the router. So console basically is the password to be used for first level password protection if you're doing console, and for VTY basically if you try to remote access using telnet, that will be the password they are using. So other than that, what are the other things that you need to configure? All the IP addresses for the different interfaces of the router are here. And for PC1, we are actually going to manually configure the IP addresses. But for PC4, if you're going to look at the requirement later, it's going to be grabbing an address from R4, which is going to be configured as a DHCP server. So the easier configuration definitely is going to start with PC1. And based on the IP address that you can see from here, basically you just need to actually configure it accordingly. 192.168.10.10. Subnet mask /24 basically is equals to 255.255.255.0, and the gateway is 192.168.10.1. That will be the configuration that you need to do. So after you have configured the IP addresses, it's good to actually verify that the PC has actually accepted the IP addresses by doing a IP config on the command prompt itself. So when you do an IP config on the command prompt, you should be able to verify that your IP addresses, your subnet mask, as well as your default gateway are configured correctly. So that's what you need to do for the PC itself. So next, let's go on to R1, R2, R3, and R4 to actually configure the basic configuration as well as the IP addresses that is going to be assigned to the various interface. Let's start by on R4. Click on CLI, enable config T. Let me just change the font size to be bigger so that it's easier for you to see. Let's change to 12. So 12. So the first thing that we need to configure is to assign the host device name. So the command basically is just host name followed by the device name, which is R1 for this case, so that when we are dealing with the different routers, we know that which router are we working on at any point in time. Next, to assign the privileged executive mode encrypted password as class. So basically this will be enable secret followed assign Cisco as the console password as well as the VTY password. So beeline console 0 password Cisco and login. Line VTY 015 password Cisco login. Okay, so basically this will actually fulfill the first two requirements for the assignment of the device name, the encrypted previous executive password, as well as the console and B2F password. Okay, which you can see from here: host name, enable secret, and line console and line B2Y. Okay, so if you decided to test again the configuration of password, just need to do a few exit to get up to the entry point. So you can see that currently your router prompt you for a password to actually go into the user mode. So basically the password is Cisco because we configure the console password as Cisco. And when we type enable, okay, you'll find that it will prompt you for a password, which is a second level password. In this case will be Cisco. Okay, so basically, okay, this is Cisco and this is class which we have configured previously. Okay, so we're going to actually do this later on R2, R3 and R4, okay, similarly. But let's finish off the IP address configuration of the router. Okay, so you can see that this we need to configure the G0/0 interface and the S00 interface with this IP address that has been assigned. So let's go start working by interface G0/0 IP at 192.168.10.1.255.255.255.0, which is the subnet mask for /24, and we do a no shard. Okay, so when you do a no shard, you'll find that the link, okay, will start to turn green. Similarly, for interface S000 IP at 10.10.10.2 okay, which is subnet mask for /30, press enter, no shard. Okay, you'll find that for this interface, if you do no shard, it will still be red and down. The reason is because the other side of the interface is still not been configured and has not been enabled yet. Okay, so okay, let's close this now. We have fulfilled okay 1, 2, A, B, C, and D already. Okay, so let's go to the rest of the router and do the similar setup. Okay, so now we are on R2, enable config T. Okay, so let's do the hostname first, which is R2, and enable secret class line console 0 password Cisco login line BTY 015 password Cisco login, and followed by the IP addresses of the interface. So 0, 0, 0, 0 IP address 10, 10, 10, 1, 255.255.255.252, no shard. Interface S001, IP at 172.16.95.1, okay, IP at 172.16.95.1, 255.255.255.252, no shard again. Okay, so we have configured okay the two interface on R2. Let's proceed on to R3 now. Do the same thing again. Enable config T, host name R3, enable secret class line console 0 password Cisco login line BTY 015 password Cisco login. Okay, next we are going to configure the interface for R3. Interface S001, IP address 172.16.95.2, 255.255.255.252, no shut. And interface S000, IP at 172.6, IP at 172.16.102.2, 255.255.255.252 for subnet mask /30, no shut. Okay, so next we're going to the last router. Okay, so CLI again. Okay, type no because this is a new router that we just started up. Enable config T. Okay, same thing, hostname R4. Enable secret. Okay, class line console 0 password Cisco login line VTY 015 password Cisco login. And the two interface S000, IP address 172.16.102.1, 255.255.255.252, no shut. Interface G0/1, IP address IP at 172.16.222.1, 255.255.255.0, no shut. Okay, so after you configure all the basic configuration as well as the IP addresses for interface, if you want to verify, okay, you can do a show run to verify all the basic configuration like the hostname, the enable secret password, okay, and the line console and the line VTY password. Okay, for interface IP addresses, definitely you can see it under the part whereby you look at the IP addresses of the interface. So just ensure that IP addresses are being configured correctly as well as no shut. But a more better command to actually verify if we can do show IP interface brief, okay, whereby you will be able to see things like the IP addresses that has been configured on the correct interfaces as well as whether you have actually do a no shut on the interface. So if you see any interface that is administratively down, means that you have not done a no shut on the interface. Okay, so you can actually verify this on all the router. Okay, so if you configure wrong IP addresses, basically you just need to go back and retype the command. Okay, so after configuring the interfaces and ensuring that all the interface links are green and up and running, okay, the next phase of the configuration basically is to configure the necessary static route as well as dynamic routing protocol on the topology. Okay, so let's analyze what we need to do first, which is this part. So you can see that for this lab, basically we are going to configure routing protocol OSPF on R1, R2, and R3. Okay, so basically the OSPF is going to involve only R1, R2, and R3. And from R3 to PC4 network, which is R4, we're going to use a static route pointing to PC4 network. And for R4, we're going to configure default route. Okay, makes sense because on the other side of router R4, it actually have a lot of other different segments on network. So a default route will basically covers all the other network or subnet that needs to be connected. Okay, so if you look at the diagram, basically you can actually safely identify that you need to configure OSPF between R1, R2, and R3. Okay, so that means that your OSPF on R3 will be a bit tricky. You only need to involve the 0001 network or subnet. Okay, where else for R3 to R4 network, basically you're going to configure a static route. Okay, and when we talk about R4 going back to the rest of the network, we are going to configure a default route. Okay, which basically represent any network that R4 can reach. Okay, so later on you'll find that later on when you configure a static on R3, you'll find that only R3 know how to go to R4. but not R1 and R2. So we're going to need to do an additional command on R3 to actually instruct R3 to share the static route, okay, with R1 and R2 through the OSPF process, basically using the redistribute command. Okay. But understanding the concept of what is the requirement of this lab, okay, let's continue. Okay, so R1 very straightforward because the whole router is in the OSPF region. So let's log in Cisco for the console password. Okay, enable password is class. Okay, config key. Okay, so process ID we're going to use. Okay, for this network basically will be process ID 1. So basically router OSPF 1. Okay, but always do a do show IP route to actually use the routing information to help you to configure the routing protocol. Okay, so this is what you're going to see, two pair of C and L because we have two interface here. So we'll start by router OSPF1. Okay, then network. Okay, so we're going to include the 2C, 10.10.10.0. Okay, /30 is 0.0.0.3 for the wildcard mask, and okay, area 0. Okay, because we're only doing a single area OSPF configuration. Same thing, network 192.168.10.0. Okay, wildcard mask for /24 is 0.0.0.255, area 0. Okay, so basically that is what you actually need to configure. Okay, for the Dynamic Routing Pro OSPF for R1. Next we go to R2. So R2 same thing, the whole router is in the OSPF area. Login Cisco, enable class. Okay, config T. So same thing, do show IP route. Okay, and router OSPF1 network 10.10.10.0, 0.0.0.3, area 0, network 172.16.95.0. Okay, wildcard mask for /30 is okay. Wildcard mask for /30 is 0.0.0.3 again. So network 172.16.95.0, 0.0.0.3, area 0. Okay, you can see that there are system message populated to indicate that R1 and R2 have actually established adjacency or neighborship already. Okay, so next we're going to go to R3. Okay, R3. So same thing. To show IP route, then router OSPF1. Okay, so be careful for this router. We only going to include the network for S001 because for the network for S000 is the network that is connected to R4. So we're not going to involve R4 in the OSPF process. So network. So S001 IP address is 172.16.95.0, 0.0.0.3 for /30 and area 0. Okay, so that is all the OSPF dynamic routing flow that you need to actually do. So how to verify OSPF configuration process? You can definitely do a do show IP protocol to verify all the configuration that you've done. At the same time, once the router has established adjacency, you can do a do show IP route. Okay, to look at what are the network that has been shared between the router R1, R2, and R3. Okay, so by doing this configuration, you will have meet the requirement of configure routing protocol OSPF on R1, R2, and R3. Okay, so I'm not going to do F yet because of redistribution of the static route. So I'm going to do the static route as well as the default route first. So for the static route, you can see that I'm going to configure static route on R3 to PC4 network using the exit interface. Okay, exit interface. Okay, so basically, I'm going to configure R3 to go to R4 network which is the 172.16.222 network, okay, using the exit interface, which is S000. Okay, so let's do that now. So IP route 172.16.222.0, okay, 255.255.255.0. Okay, so the exit interface is S000, S000. Okay, so you have configured static route. So you can do a show IP route to verify that the static route has been configured. So you can see that currently I have a static route pointing to 172.16.222.0. Okay, so as I mentioned, you only configure a static route on R3 to reach R4 network. But does R2 and R1 know about it? So if you do a show IP route on R1 and R2, in this case I'm doing R2 first, you will find that there is no destination network of 172.16.222.0. Similarly, if you do it on R1, do a show IP route, okay, you will find that there is also no destination network 172.16.222. So if R1 and R2 doesn't know about the 172.16.222 network, you will find that PC1 definitely will not be able to reach PC4. Okay, due to the reason R1 and R2 doesn't know how to go to PC4 network. Okay, so in order to there are two ways to do this. Either you actually configure static route on R1, R2, okay, but this is not efficient, also not scalable, because if you've got a lot of router, you're going to do the same thing again and again. So on dynamic routing protocol itself, we are able to do redistribution, okay, of any static route or even the default route that you have. So let's go back to router OSPF1, and we're going to do this new command which is called distribute, okay, static subnet. Okay, so as the name suggests, we're going to actually ask OSPF to help us to redistribute any subnet, any static, okay, route that has been configured on R3. Okay, so after doing this command, if you were to go to R2 and do a show IP route again, okay, you will actually be able to see, okay, the 172.16.222 network, and it's been shared through OSPF. Compared to previously, you actually cannot see the network. So this is how you can actually instruct dynamic routing protocol to help you to share a static route that has been configured on a particular route. So the next part basically is to configure a default route on R4. Okay, but in this case, I'm using the next hop address. So on R4, I'm going to configure a default route, okay, pointing to R3 next hop address, which will be the IP address of S000 on R3. So let's go into the router, login, Cisco, enable class, config T. So IP route. So default static route is easiest to configure. Don't even care about network address. Everything is 0, and the subnet mask is also all 0. Okay, but we need to use the next hop address. So we need to find out the R3S00. So R3S00 is 172.16.102.2. So 172.16.102.2. Okay, so that's it. That is the default routing configure. So if you do a show IP route, okay, you will get to see the default route that you have configured on R4. Okay, so due to the reason that PC4 don't have any IP address yet, we won't be able to test the connectivity. Okay, so now if you were to go to I requirement, you are supposed to configure DHCP pool revision on R4 to issue, okay, PC4 with 172.16.222.10 address. So we need to actually exclude the first 9 address in order for PC4 to grab .10. So go to router R4, IP DHCP excluded address. We're going to block 172.16.222.1 all the way to 172.16.222.9. okay, so that it will start issuing address from .10 onwards. Okay, and then we're going to create a IP DHCP pool, okay, with a name revision as mentioned here. Okay, and the next range of IP addresses will be 172.16.222.0 with the subnet mask of /24 255.255.255.0. Okay, and the default gateway address or the default router will be 172.16.222.1. Okay, okay. Actually, you can see that, okay, basically the gateway is pointing to the interface of R4, which is the default router. Okay, so after doing this, if you were to go to PC4, okay, desktop and IP config from static, if you change to DHCP, if the configuration is successful, you will find that your PC4 will successfully grab the correct IP addresses with the subnet mask as well as the default gateway. Okay, so from PC1, now we can actually do a connectivity test by doing a ping 172.16.222.10. Okay, let's wait for the output. Okay, so you can see that we can successfully get a reply from PC10. So it means that, okay, the dynamic routing protocol as well as the static route as well as the default has been configured successfully. Okay, in order for the different subnet or network to be able to reach each other. Okay, so the next basically, okay, is to do, okay, another portion of the requirement, which is configure access list. So the here mentioned that you're supposed to configure a standard access list with ID 25 on R4 to permit PC1 to ping PC4 only. Okay, and you're going to apply it on the interface G0/1. Okay, makes sense because when you configure a standard access list, the best practice is to locate it as close as possible, okay, to the destination. So let's go to R4. Okay, so access list 25, and we're going to permit, okay, PC1 network or PC1 address, okay, which is host. We're going to use host and 192.168.10.10. Okay, so you don't have to do a deny any because every access list, the last line is always an implicit deny any statement. Okay, and we're going to apply this to the interface G0/1 IP access 25 out. Okay, the reason why are we configuring it out because we are trying to inference the traffic from here to here. Okay, so basically the traffic is going out of R4. Okay, that's why it's up interface. Okay, so you can see that after you have configured this, okay, access list and you actually enable it. Okay, since this is still .10, definitely I will still be able to ping. Okay, so the ping is still successful. Okay, but you want to test it out, you can actually change it to a different address, like for example .12. Okay, and you're going to try to ping it. Okay, you can see that you're going to get destination host unreachable. This shows that your access list is now working as what you configure it to be. Okay, so you go to R4 and you do show access list command. Okay, okay, you can see that, okay, okay, there are 4 matches for the ping. Okay, so as mentioned, there is an implicit deny any statement that is hidden. That's the reason why you cannot see the matches when it actually responded to the destination host unreachable. Okay, so other than this configuration, if you decided to enable statistic monitoring by configuring net flow, okay, for example, let's say I want to configure net flow on R1 to actually monitor the different type of traffic that flow through the interface, you can go to R1. Okay, and in order to enable net flow, okay, basically you, okay, need to actually configure it to forward the traffic to which PC or server for the net flow to be displayed. You can do net IP flow export destination. Okay, let's forward the statistic to the PC1 192.168.10.10. Okay, and the default port number used by NetFlow is 9996. Okay, and let's enable NetFlow to monitor incoming outgoing traffic for both gigabit 00 interface as well as 000 interface. So let's go to the blue interface and do an IP flow ingress and IP flow egress. Oops. IP flow egress. Same thing, interface as 000, IP flow ingress and IP flow egress. Okay, so that's it. Very simple command to enable NetFlow monitoring. Okay, so on PC1 you can go to the NetFlow collector, turn it on. Okay, so after a while it will be populated if you actually simulate any traffic that goes through the different interface. Okay, so for example, let's say let's try to simulate some ping traffic. Okay, so let's ping PC4 again. Okay, so we will get a reply. So if you're on the router, if you want to verify whether the NetFlow is working, you can do a do show IP cache flow, okay, to look at the statistic. Okay, so sometimes it takes a while for the router to actually capture the traffic that is being sent through the interface. Okay, we want to do a few times. Okay, so we can see that I've successfully captured the ICMP traffic. Okay, and there are also traffic coming from multicast address 224.0.0.5, which is basically due to the multicast address used by OSPF, communication between the router. Okay, so if you want to see telnet also can. You can actually do a telnet to the router interface. Then that's it. Two. Okay, let's do one. Okay, password is Cisco for VTY. So you can see that now I'm actually accessing R2. So same thing, if you go to R1 and do a do show IP flow, as I mentioned, it takes a while for the traffic to be displayed. Can see there are ICMP traffic that has been captured as well as telnet traffic that has been captured. So on the NetFlow collector, if you go back to the PC again, you can see that it's displayed in the graphical method. So depending on the software they install, you can see the different types of traffic and the amount of traffic that flow through the different